First, here we consider a single slit experiment. The pattern can be considered as the superposition of a single slit diffraction in a from each hole or slit and a double slit interference pattern. So this is just a superposition of these two effects. This is shown in the figure, and you can show the graph in a broader diffraction peak in which there appears several fringes of smaller width due to the double slit interference. So it is diffraction plus interference. The number of interference fringes occurring in this broad diffraction peak depends on the ratio d by a. That is, d means distance between two slits and a means width of the slit. In the limit of a becoming very small, the diffraction pattern will become very flat, and we will observe the two slit interference pattern. That means the same interference pattern you can see when we approach the limit a becomes very small. Next, we think what happens if we close one slit in the double slit interference experiment. You can see that this source can be this source gives a one hole or one slit, S1 or S2, and this will produce a single slit diffraction pattern on the screen. And you know that the central bright fringe will appear at a point which lies in the straight line S1, SS1 or SS2. That is the difference. Now we compare and contrast the interference pattern with the diffraction pattern. In this first point, we can say that the interference pattern has a number of equally spaced bright and dark bands. Second point means the contrast, the diffraction pattern has a central maximum which is twice as wide as the other maxima. Other means the next consecutive maxima, and the intensity falls as we go to the successive maxima away from the center on either sides. These are the first point. When we go to the second point, we can say that the interference pattern by superimposing two waves from two narrow slits. The diffraction pattern is a superposition of continuous waves from each point on a single slit. So first one, it is from two slits, and another one, it is from one slit. And third point, for a single slit of width a, the first null occurs at lambda by a. Same angle lambda by a, we get a maximum from the two slit experiment. These are the difference between interference and diffraction pattern. Next one, when we consider this d and a, we can say that d is a distance for good interference and diffraction pattern. We can consider d as the order of millimeters, a millimeter or so, and we can consider the width a as 0.1 millimeter or 0.2 millimeter. And next point is, when we consider this Young's experiment and single slit diffraction pattern, we consider the screen at a large distance. For this, we can consider two or more paths from the slit to the screen were treated as parallel. This situation also occurs when we place a converging lens after the slits and place the screen at the focus. So this parallel path are combined at a single point on the screen. Note that this lens does not introduce any extra path differences in the parallel beam. This arrangement is used because the intensity it is far away will not give more intensity because the screen is far away, and if f is the focus, you know that at lambda by a we have a central maximum, so that the size on the screen when we use a lens is f into lambda by a. That is the difference.